Unit 3 in Artificial Intelligence Knowledge Representation. What is knowledge? Knowledge is nothing but facts, informations, and skills that are required through experience or education. Once this knowledge is acquired, we have to represent those knowledge. So, the representation of information about the real world in some formal language is called as knowledge representation. It also enables the machine to learn from the knowledge and experiences so that it can believe or behave intelligently like an human. Let us consider the following diagram which contains sensor. So here the sensor is given. So the sensor sends the information and collect the information. So from this information a knowledge base is created, and from this knowledge base is created on a machine. With this knowledge it makes the decision, and moves towards the goal. So this is regarding the knowledge representation. So there are different techniques used for knowledge representation. First one is propositional logic. First one is propositional logic, first order logic, rule based system, semantic network, frames, and scripts. So these are all about the knowledge representation techniques. First one is propositional logic. So this propositional logic represent the facts which are either true or false. Propositional logic represent the facts which is true or false. There are 7 days in a week which is true. The questions which answers true or false forms the propositional logic here. The sun rises from the west, which is false. So 3 plus 3 is equal to 7, which is false. So propositional logic is also called as Boolean logic as it works on zeros and ones. So statements which are questions, commands, or opinions are not propositions, such as how are you, what is your name, are not propositions. Symbols such as A, B, C, P, Q, R, etc., and connectives such as and, or, negations, implies, and by implies. So these are all the connectives used in propositional logic. So propositional logic connectivities. So there are different connectivities used in propositional logic, such as conjunction, disjunction, negation, conditions, and biconditions. So these are all the connectives used in the propositional logic. So the conjunctives means it performs and operation, disjunctive means it performs or operation, and negation means it performs not operation, and condition which implies if then operation, by condition it performs if and only if operation. So translations of sentence to propositional logic. So let us consider Peter can play tennis. So assume this as a statement or English sentence. So here we can assume this sentence as a propositional logic term P. So Peter cannot play tennis. It can be represented by negation of P, where it means that cannot play. So where Peter cannot play. Next is Peter can play tennis and badminton. So which means, so Peter can play tennis and Peter can play badminton. So it can be represented by the propositional logic P and Q. Next is Peter can play tennis or badminton. So Peter can play Peter can play tennis or badminton. So the the statement P which indicates Peter plays tennis, and statement Q which represent Peter plays badminton. So it is represented or it is connected by using the connective or. So if Peter can play tennis, then he can play badminton. So if then has come, so we can use imply statement. So P implies Q. So Peter can play tennis if and only if he can play badminton. So here you can use bidirectional, that is by conditions. Next is truth table. Once the propositional logic or Boolean logic is represented, it can be represented by using the truth table, that is P and Q. If P and Q are the two statements, it is two Boolean variables can be formed from the statement. So out of two Boolean variables, four possible combinations can be framed. So true, 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 false, false, true, and false, false. So P and Q, we can get the values. P or Q, we can get the values. P implies Q, we can get the values. P bidirectionals or biconditionals, we can get the values like this. And P negation is nothing but negation of the statement P. So next representation is first order logic. In first order, in propositional logic, we can only represent the facts which are either true or false. That is example, is it raining? But in propositional logic, it is not sufficient to express or to represent the following statements such as some and all. Some humans are intelligent, all mangoes are sweet. So for this, we go for first order logic, which is also called as predicate logic. So first order logic specifies objects, relations, and functions. So first order logic syntax. So functions terms, function inside of functions, you can have term 1, term 2, etc. up to term 1. Or predicate in terms of term 1, term 2, and term 1. Example, X is a girl. So X is a subject and girl is a predicate. So this can be formulated as first order logic, girl of X. Next is quantifiers. There are two types of quantifiers, universal quantifier and existential quantifier. Universal quantifier can be represented as for A, that is for all. For all, this can be represented as for all. For some, there exists nothing but for some. All employees, for all X, employee of X. Some students, there exist X, students of X. So students, this X represent one of the student among them. So this can be represent there exist. Next, elements of first order logics. So there are different elements of first order logics. One is constants, variables, predicates, functions, connectives, equalities, and quantifiers. So as we all see the quantifiers, equalities is nothing but equal to symbols, and connectives we have different connectives, and functions we have predicates, this is, and this is variable and constants. FOL example. Sam is tall. Who is tall? Sam. So tall of Sam. So John likes cricket. So who likes the cricket? John likes. So likes is a predicate here. So likes of John, comma, cricket. Everyone likes cricket. So here we have everyone. So we have using for all X, likes of X, comma, cricket. All students like cricket. For all X, students of X implies, so all likes. So we are using biconditionals. For all it comes means you have to use conditional statements. That is if then statement. For all X, student of X implies likes of X, comma, cricket. Some boys are intelligent. So there exists X, boys of X, and intelligent of X. Likewise, we can form. So here are some statements. You can take it as practice and you can convert it to the FOL statements. Next topic is unification. So unification is the process used to find the substitution that makes different FOL expressions looks identical. So for example, let us consider, we'll go to the algorithm later. So let us consider the two statement, unify nose of John, comma, X, and nose of John, comma, Johnny. So here nose is an predicate here. So it has two variables. One is John, comma, X. So here the function which has two variables, that is two arguments, that is John, comma, X. So first argument among these two are same. The second argument is X and John. So this X can be replaced by Johnny. So once we are replacing this two FOL looks like a identical. So let us consider the same example. Unify, we are going to unify which two, which one? Nose of John, comma, X, and nose of John, comma, Johnny. So X can be replaced by Johnny. So the unification is theta equal to x given Jan A. So x must be replaced by Jan A. So now goes to the algorithm. Algorithm unification, unify expression 1, expression 2. So step 1, what you have to do? Check if either expression is a variable or a constant. So you have to check whether it is the expression is either variable or a constant. You have to check. Then step 2, compare the number of predicates. How many predicates are there? You have to check. Then verify the number of arguments. So here the number of arguments is 2. Likewise, you have to check the 2 FOL. In 2 FOL, predicate must be same and the number of argument must be same. So create an empty substitution set, that is theta. Attempt to unify each argument recursively. So you have to unify the arguments. Both the arguments you have to unify recursively. Then return the MGU. What is MGU? Most general unifier. So let us see some other example. Unify nose of John comma X, nose of Y comma Bill. What is the algorithm? Algorithm says first you have to see the predicates of two FOL. Here also nose, here also nose. Then arguments. Two arguments are same. John X, Y comma Bill. So what you have to do? We have to replace X by Bill and Y by John. So we can replace this X by Bill. So this first FOL will become as nose of John comma Bill and nose of Y comma Bill. So this Y can be replaced by John. So what finally, so this is the MGU, this is most general unifier. Theta is equal to X to be replaced by Bill and Y to be replaced by John. So this is the example for unification. Next topic is inference engine. So inference is nothing but, so you'll be having some human experts. From human experts we can collect the information, and this informations along with certain rules forms the knowledge base. From this knowledge base, inference engine will match the rules with the facts, and then user will get the information. It will give the informations, or it will get the information from users can get the information from the inference engine. So it applies logical rules to the knowledge base to infer new information from the known facts. So from the facts we can know the information. So inference engines commonly proceeds in two modes. What are the two modes? One is we can proceed in two ways. One is forward chaining, another one is backward chaining. So first one is forward chaining. So forward chaining starts with the available data. The available data is facts. So it will hold the facts and then use the rules, and then it goes to the conclusion. In a reverse way, backward chaining works. It will take the conclusion. From goal, we will proceed. From goal, that is from conclusion, we will use the rules and we will arrive at the facts. So this is two types of inference. One is forward chaining, another one is backward chaining. So in forward chaining, we will tell what will happen next. In backward chaining, why did this happen? We will tell. So this is bottom up approach and this is top down approach. So this is bottom up approach and this is top down approach. So next is forward chaining example. It is raining. We can make this as A. If it is raining, then the streets are wet. So A is raining, so B is wet. The street is wet, so B is street is wet. So from facts, what we have the facts here? A. From A, we will use the rule A implies B. At last, you will get the conclusion B. So this is forward chaining. So whereas backward chaining, we can consider the backward chaining here. The street is wet. The conclusion is B. Conclude from B, street is wet. If it is raining, the street is wet. So A implies B, and last we'll get A as fact. So here we have an example. The law says that it is crime for an American to sell weapon to the hostile nation. Country Q, an enemy country of America, has some hostile nation, and all of its missiles were sold to it by Jack, who is an American. Prove that Jack is criminal. So the statements can be splitted into, this paragraph can be splitted into different statements. Then the statements can be converted to FOL. We have to split it into different statement and we have to follow this and we have to frame it as an FOL. From FOL, we have to take the facts, rules and conclusion and proceed in the forward chain manner. What is facts? Facts is nothing but the statement which does not have implies, those are called as facts. So these are all the facts. Owns of, missiles of, then American of Jack and enemy of Q, America. So these are all the facts. Then what is the rule here? So we have to write the facts at the bottom. Next, step 2. What is the rule here? Rules that satisfy the facts. So we have to take where all we have implies in the FOL, we have to check. So first, what is the facts here? Owns. So where the owns match here, here it matches here. So we can write cell of Jack, X, Q. So missile, what he can sell? Jack can sell the missile. To whom? Q. So missile and owns. This you can match. Likewise, next, what is the next fact here? American. American of Jack. American, to which it match? Where it matches? American. American matches with the with this we can match it. Here we have an American of crime, we can match it. Next what is the implies here? Next, what is the facts here? Owns. Where it owns matches? So here. So cell of Jack. So this we can use it. So cell of Jack you can take. That is, after implies what we have to write here. Next to hostile also we can return. So enemy of Jack implies to hostile. So hostile we have written. Okay. At last what we have to do? We have to arrive to a conclusion. So conclusion, what is the conclusion? That so all these facts and rules finally says that crime of Jack. All at last implies that America, weapon, cell and hostile implies that criminal of X, who is a Jack. So if you're going in a forward way, this is forward chaining. Next, backward chaining, we have to start from criminal of Jack and then we have to move downward. What is here? So criminal, from criminal, what is the opposites there? America, weapon, cell and hostile, you have to return down. Then what are all the things which matches with that? We have to take and hold it. So next step is that. So at last we will come to the facts. So this is facts, this is conclusion, this is rules, and this is facts. Next is resolution. What is resolution? Resolution is nothing but proof by contradiction. So next topic is resolution. So resolution is a logical method that is used to validate the statement by showing that assuming the negation leads to contradiction. That is proof by contradiction. So we have to show the proof by means of saying the conclusion as a contradiction. So that is resolution. So steps in resolution. So you have different steps in resolution. First, what you have to do? You have to convert the statements into FOL. Step 2, what you have to do? You have to convert the FOL into CNF. That is causal form. How you can convert FOL to CNF? So you will be having different rules. One is removing implication. Next, moving negation inward. Then standardizing the variable and applies columnization, then drop universal quantifier. So this all 5 steps put together forms the conversion of FOL to CNF. Next, what you have to do, you have to negate the assertion to be verified. Negate the assertion is like that you have to negate the conclusion. At last, you have to draw the resolution graph and apply unification. Right, first, let us consider the example. A implies B, B implies C, and A prove that C. First, what we have to do? We have to take the FOL and convert it to CNF. How we can convert to CNF? We have to remove the implies. How you can remove? You can use negation. So A implies B can be replaced by negation of A or B. So this A implies B is written as negation of A implies, so negation of A or B. Next, similarly, B implies C is written as negation of B or C. At last A. Then you have to, what you have to do? You have to negate the goal. What is the goal here? C is the goal. You have to prove C. So we have to take it in a negated form or contradicted form, C. Right? We have to draw the resolution. First, you have to take the goal, negation of C. the negated term is matching with which term you have to check. So here negation of C. So without negation there is a term negation of B or C. So this term we can use it. By using this two we can eliminate negation of C and C. So remaining term is B. Negation of B we will get separately. So this B and this term you have to write. So here this negation of B and B will get vanished. Then you will get it as A. This A and finally A you can use, and finally you will arrive to the conclusion as proved. Once the null statement is received, you can say it as proved. So it's a simple example. Let us consider the following example. John likes all kind of food. Apple and vegetables are food. Something anyone, anything anyone eats and not kill its food is food. Anil eats peanut and still alive. Prove by resolution that John likes peanut. You have to prove this. So first what do you have to do? Convert the facts into FOL. So we are converting the facts into FOL. So first John likes all kinds of food. So for all x, f of x implies, so all, so we are using for all x. So since we have received for all, you have to use implies. Apples and vegetables are foods. So food of apple and food of vegetable. Anything, anyone. So for all x, for all y. So you have to frame like this. We are converting the facts into FOL. Second step, we have to reduce the FOL to CNF. How we can use? You have to use 5 steps what I discussed earlier. First, what you have to use? You can remove the implies. Then, how we can remove the implies? You have to replace A implies B as negation of A or B. So this you can use, and you can use De Morgan's law. That is, we are bringing inward the negation. Then we can have the CNF like this. Next, what is the step 3? You have to negate the proof. What do you have to do? John likes peanut. So likes of John comma P is the actual FOL. So you have to negate. So we are negating this. Next, what you have to do? You have to draw the resolution graph and apply unification. Okay. First, you have to, what you have to do? You have to take the conclusion. Negation of likes John of peanut. What assertion is matching with this? We have to take. So likes, where it comes likes here. So this two you can write. Likes and likes get cancelled. So you will get the remaining as food. Food of negation of food of x. Where the food term has present, we have to take this. You have to use this. Likewise, if you proceed, you can get empty, it is null. So here you have another 2 problems. You can use it as example and you can solve and see. The next topic in unit 3 is knowledge representation in AI. So knowledge representation in AI refers to encoding informations about the world in the format the AI system can utilize to solve a complex problem. So this is knowledge representation cycle. First, what you have to do? The machine will acquire, or knowledge acquisition phase will occur. Then you have to represent the acquired knowledge, and from the representation you have to process and reason the knowledge. Once the knowledge is processed and reasoned, you have to utilize the knowledge, and last you have to refine, and learning has to be taken place. So this is knowledge representation for a machine. So generally data is organized and analyzed to form an information. Once the information is arrived, it is interpreted and evaluated to form a knowledge. Once the knowledge is arrived, the knowledge principles of understanding the knowledge will become a wisdom. So elements of knowledge representation. What are the elements of knowledge representation? Objects, events, performs, meta-knowledge, facts, and knowledge base. So these are the elements in knowledge representation. So types of knowledge. What are the types of knowledge? You'll have different types of knowledge. One is declarative knowledge, heuristic knowledge, meta-knowledge, procedural knowledge, and structural knowledge. Declarative knowledge is to know about something, includes concept, facts, and object. Procedural knowledge is also known as imperative knowledge. It's a type of knowledge is responsible for knowing how to do something. So it is a procedure of knowing something. Meta-knowledge is about knowing about the other types of knowledge. Heuristic knowledge, knowledge of some experts in field or subjects. That's a thumb of rule. Heuristic knowledge is a thumb of rule based on previous experience. Structural knowledge is nothing but basic knowledge to problem solving. Next is different knowledge representation techniques. One is logical representation, semantics network, production rule, and frames representation. Logic representation is nothing but drawing a conclusion based on various conditions. You have to arrive to a conclusion based on different conditions. Example, we can have syntax, each sentence can be translated into logics by using syntax and semantics. Syntax is nothing but you have to use rules which decides how we can construct a legal statement. Semantics is nothing but rules by which we can interpret those statements. Next is semantic network. It is an alternative predicate logic. Here you will be having a network, semantic network. The nodes represent the object and the arc represent the relation between those objects. So there is an inheritance relation, is a relation, some kind of relation. Example, let us consider this semantic network. So this semantic network we can consider white and Priya. So these are all the nodes: white, Priya, Jerry, cat, animal, and mammal. So Jerry is a cat, is a relation. So this is a relation between the two nodes. Cat is a mammal is a animal. So Jerry is colored with white. Jerry is owned by Priya. So it is a semantic network. Next is production rule. Production rule is nothing but if then conditions. If conditions, then action. So for example, if at bus stop and bus arrives. So if you are at bus stop and the bus arrives, then what is the action? You'll get into the bus. Okay, so this is an example for production rule. If condition, then action. So in production rule, agent checks the condition. If the condition exists, then production rule will fire and corresponding action will be triggered or carried out. So if on bus and paid and the empty seat. So if you are getting into the bus and you are paying and getting a ticket, and once the seat is empty, then what is the action? You will sit down in the seat. Similarly, other actions also can be taken. Last representation is frame representation. A frame is like a record-like structure which consists of collections of attributes and values. So it consists of collections of slots and slot values. For example, here the slot is title. It is a frame-like structure I told. So slot here title. Filter is the value of the slot, that is artificial intelligence. Generi is, it belongs to the computer science. Author is Tom Towley. Then edition is third edition, year and pages. So this is regarding the knowledge representation techniques. Next is ontologic engineering. So ontologic engineering is a crucial part of AI that focus on creating structured framework to represent the knowledge. So it is creating a framework to represent a structured knowledge. What is ontology? And in artificial intelligence, ontology refers to a formal framework that defines a structured way to represent the knowledge. So it is a way of representing the knowledge. So what are the importance of ontologic? So ontologic is used for knowledge representation, semantic web, NLP, and for decision making. Next is classification of ontology. How the ontology is classified? It's based on four things. One is domain ontology, task ontology, application ontology, and upper ontology. Domain is nothing but on a particular domain how a framework works. The domain ontology describes the concepts and relationships specific to a particular field or a domain. Example, healthcare ontology. It defines the medical concepts such as disease, symptoms, treatments, and their relation in a particular domain. Task ontology, it focuses on a particular action required to achieve a specific task. Example, part picking robot. We can take a part picking robot or a robotic process automation. It defines an action like navigate, pick object, and placed object. So task ontology, it is a process and action required for achieving some specific task. Next, application ontology are tailored or specified applications and focus on solving problem in a particular industry, such as, so it is based on specific applications such as finance, legal, or some of the application ontology. Upper ontology provides a high level framework for knowledge representation across various domain. So basic formal ontology, general formal ontology. Next, components of ontology. So there are different components such as individuals, class, attributes, relations. Individuals represent the most basic and specific objects or an entity in an, so it is a basic thing in an ontology. Class is nothing but class or group or set of individuals that shares the common characteristics. In medical ontology, class is disease and individuals are diabetes, hypertension. So class hierarchy. Classes are often organized into hierarchies such as subclass and superclass. So superclass is vehicle and subclass is car and bike. Attributes. Attributes are the properties or characteristics of an individual. So for example, so in product ontology, individual is laptop and their attributes are prices, weights, and brands. Attributes. So types of attributes are numerical attributes and textual attributes. Numerical attributes like price, weight, and age, and the textual attributes such as name, description, and location. Relation defines the connection between the individuals and the class attributes in an ontology. They specify a meaningful relation within a knowledge base. So types of relation. What are the types of relation? Hierarchical relation and associative relations. So different ontology languages. So there will be different ontology languages such as SISL, Rule Interface Format RIF, Open Biomedical Ontology OBO, Web Ontology Language OWL. So these are all the different languages used in ontology. So next topic is categories and objects. So categories and objects, two types of representation. One is predicates, objects. So in predicates, basketball, where B is a ball which belongs to basketball category. Object, basketballs, members, B comma basketball subset. A ball can be a basketball. It is represented as an A, B. Inheritance. A fruit is a subclass of food. An apple is a subclass of fruit. Therefore, apples are edible. So it is regarding the classes and or categories and objects. Next, events. So events are treated as true independence of time. So event is nothing but any thing that happens, any process that happens within a time duration, that is called as events. Need to describe what is true when something is happen. For example, flying events. So flyer of E comma Shankar, origin. So Shankar flies from where? By using E as a flight from San Francisco to Baltimore. So this is source and this is destination. Next is event algebra, Allen algebra. So meet of two intervals meets if the end time of first equals the start time of a second. So two events meet if the end time of the first equals the start time of the second. So when the event 2 ends, it becomes the start time of the second event. So this is event algebra. So meet of I comma j. So I event ends at the same time it starts with a new event j. Before I comma j, after j comma I. So I event I occurs and finish. There is a pause and then event j starts and finish during. So j starts, it proceeds. Within j, I starts and finish it. That is during. Overlap. So I starts and proceed. In the meantime, j starts after some duration of I and j proceeds, but I ends. Start of I comma j. So starting time of two events are same. Finish of I. End time of two events are same. Equals of I comma j. Both the event starts and ends with the same time. So this is predicates on time, predicates on time intervals. That is based on Allen time algebra. Mendel event and Mendel object. So far, KB agent, knowledge-based agents can have belief and deduce new beliefs. So whereas what about knowledge about belief? So, what about knowledge about the inference process? Requires a model of mental objects in some head and process the manipulation of these objects. So, what a human brain thinks, what it happens, how those things can be represented. So, those forms the mental event and mental objects categories. So, this is the last. So, what is category? So, the organization of objects into categories is a vital role of knowledge representation. So, although interaction with the world takes place at the level of individual objects, much reasoning takes place at the level of categories. So you'll be having a interaction in terms of object, but it may happens in terms of category only. So this is regarding the unit 3 knowledge representations, events and objects, and in unit 3 of artificial intelligence. Thank you.